Hello guys, I welcome you once again to follow me along on one of my Scrapyard adventures. We meet again at a point in time that I would characterize as one of perceived false normalcy and a somewhat disappointing longing for the mundane. Indeed, going back to normal was a mantra of the last few years, and I'm pretty sure that many of you have wondered what was so great about that normalcy in the first place. On top of this longing for normal times to live in, there is an outright fascination with the mundane. When I started filming material for my first videos about 10 years ago, I expected that what the internet and the world would be waiting for would be the unusual, the special, exploring, getting surprised by the complexity of the world, acquiring knowledge that was really hard to come by before the advent of the internet. And what can I say after 10 years of putting my blood, sweat and tears into presenting something interesting to the world? My own accomplishments are of course dwarfed by the internet's version of reality TV. It's the victory of the vapid and the mundane. At the same time, especially considering how disappointing a lot of the stuff on these platforms here is, I'm still proud that so many of you have come here again today to see what I want to show you. We have all come here together without any external pressure and without any institutional support or funding, choosing to spend our time with unusual, sometimes even challenging things. In that sense, come and follow me along and let's see what we can find here today. This is a massive transformer that we can modify to generate enormous amounts of electric current, and that's exactly what we're going to do today. Here, a local metalworking business has dumped a lot of stuff. I bought a lot of the stock you see scattered here. But there is also something very special between all of it. A heavy spot welder that we will take to the shop as well. This massive welding machine here was made by the same company. Unfortunately, I don't have the means to haul it off right now. After leaving the scrapyard, I also found something cool in this thrift store. This 1960s stereo system is a diamond in the rough, as you will see. On top of that, we will also experiment on a number of other transformers that I have collected over the years. So let's get going then. A pretty exciting scrapyard find is this massive transformer here. Rated at 5 kVA maximum apparent power and weighing in at around 35 kilograms or about 77 pounds, it might have been used on a welding machine or a massive battery charger in its first life. Rated output current for the original secondary is 200 amps. This particular construction style, where the secondary winding is located above the primary in a separate spot, lends itself to some ultra-high current experiments, and that's what we're going to do in this video. A while ago I also found this wire on one of the scrapyards. With a cross-section area of 150 square millimeters, it is literally off the charts. Which chart? Well, the normal American wire gauge chart, which seems to end at 107 square millimeters. We will use this wire as our new secondary winding to induce some serious current. But first, the old secondary has to go. The way I do it in this case is to cut through the turns with an angle grinder. If you plan on doing this yourself, better make sure to wear a mask when doing this and remove the dust that you are creating. I turn the transformer around and cut through the winding here on the flip side as well. This way it is much easier to perform the next step, which is hammering the remaining copper parts out of the core. I do this with the help of a punch. The weight of the copper from the secondary alone is around 6 kilograms. After that, we also remove the paper until only the primary winding is left. In the next step, the massive wire is wound around the mid part of the core as many times as will fit. Now we have to find out how to connect the mains voltage to the primary winding. First, the insulation is removed and the surfaces of the wire tips are scraped off. Then they are tinned with solder. First, I measure the resistances between the different leads. But with copper wire this thick, it is extremely hard to learn much from the resistance values alone, as they will all be very low and very close to each other. Measuring the inductances will tell you a lot more about what is going on. After measuring the resistances and inductances between the different leads, I put it all down on paper and figure out what's going on. From that information, I deduce that there are actually two secondaries that are connected in parallel. We will connect those to the mains voltage of 230 volts via a 5.5 kVA variac. And since I know that people will talk about microwave oven transformers when they see this setup, I decided to just compare some of them here in this video to the performance of this transformer. This is a normal microwave oven transformer. This is a big mod, and this is our Scrapyard transformer. The normal mod weighs 5 kilograms, the bigger one 7 kilograms. We will also prepare this green transformer here that I found in a dumpster and test it as well. The microwave oven transformers are prepared much in the same way as the big transformer. The secondaries are removed, and so are the magnetic shunts. In the case of the green transformer, the secondary, here sitting outside of the primary, was already a DIY solution by a former owner, and we are removing that as well. 40 and 50 square millimeter pure copper welding leads are wound on these cores. In the case of the green transformer, we can accommodate way more turns, as we can utilize the entire length of the primary winding to wind the secondary around it. And here are all the transformers with their new secondaries. And to be able to actually attach various objects to the circuit, these massive welding ground clamps are attached to the ends of the wires. They are made from brass. In order to get an idea about the amount of current that is actually flowing, I also scored this clamp meter on eBay. It's about 10 years old, but looks brand new. Its maximum rated current is 1000 amps. We will find out soon enough if that will be enough. Let's start with the smallest transformer then, and attach some normal 3mm welding rods between these clamps. We will then add more welding rods in parallel and see how many of them each transformer can melt. These are not copper wires, by the way. They are steel rods normally used for TIG welding. The smallest of the transformers needs a really long time to heat up even the single welding rod. Until it eventually melts and interrupts the circuit. In this case, we measured 269 amps. The clamp meter is set up so that it will store the highest current that was measured during the entire experiment. At 2 welding rods in parallel, we have already reached the maximum what we can do here. The transformer isn't really able to melt them. And the maximum current we have achieved is about 395 amps. The bigger microwave oven transformer will now melt 4 welding rods, which it eventually does, but it also takes a lot of time. The maximum current we got here is 649 amps. The green transformer was also able to melt 4 wires, so now I'm attaching the small wrench here. It's from a box of about 100 wrenches that I have just restored, and this one isn't of particularly great quality, so please excuse me, cut me some slack here for destroying a tool once in a while. And well, the green transformer also takes its time, but it manages to actually melt it through at 666 amps. The 5 kVA transformer manages to actually melt through the 4 welding rods in no time, and we measure 1007 amps. Might be a false reading because the ammeter is actually overloaded at this point. I want to take it up a notch from here, but we have to change a few things here because the ammeter is at its maximum range and also the circuit breakers are. So I bought yet another used clamp meter. This one is a little older, but it was made in Austria by BBC Goertz. I'm testing it here with my light bulb dummy load. At this moment it is switched to its lowest setting, which is 10 amps. The way these clamp meters work is that you have to clamp them around one of the conductors to measure AC current. This older meter has a few advantages. It is much quicker than the digital meter. The Unity meter wasn't able to measure some of the current bursts that I saw here. It needs no batteries and it also has a much higher current range. It can indeed measure up to 3000 amps. In the meantime, I had tried to melt this wrench here, but I had to reset the circuit breakers a few times because the primary current far exceeded the 16 amps of a normal outlet. This is a normal single-phase 16 amp cable. This is a 3-phase 16 amp extension, and this one is a 32 amp 3-phase cable. We're now powering the 5.5 kVA variac from the 32 amp line, between one phase and neutral, that is. We'll try our luck with this already rather damaged wrench here. The digital meter measures the primary, the analog meter the secondary current. And I think the maximum reading here was around 1200 to 1300 amps. Now I would like to again take it up a notch here, but I will need a 63 amp 3-phase power supply, I'm afraid. I will try to do that in the future, but I have to stop here for today, unfortunately. So another recent scrapyard find was this spot welder. It was made by the German company Dalex, and this is not the first time we have encountered a product by that manufacturer. This is episode 36 of the Scrapyard Repair-A-Thon series. In episode 18, we already found another Dalex spot welder. The links to all earlier episodes are down in the video description, by the way. The other spot welder was much smaller and lighter than this model though. The smaller unit was for 220 volts, while this one here is supposed to be connected to 380 volts. The secondary short circuit current is 7.5 kiloamps, meaning 7500 amps. Just for comparison, when you see me TIG welding, I'm usually welding with around 100 or maybe sometimes 150 ampere. The maximum possible current here is 50 to 75 times that. But you can't really compare those two because spot welding is a form of resistance welding, meaning that we are not striking an arc, but rather just heat up a small spot of the workpiece up to the melting point for a very short moment. Unfortunately, one of the electrodes is bent, so I'm removing it to heat it up with a propane torch to make it easier to straighten it out. So once I had done that and waited for some time for it to cool down, I reinstalled it, and this has to be done in such a way that the two electrodes meet at the right spot. It can't protrude too much or too little. This will also have to be readjusted after a while, as small portions of it will burn off as the spot welder is used. However, when I first found this tool, I wasn't sure if I would ever be able to use it, since Dalex sold it together with a box that it's supposed to be attached to. The box is then connected to a 380/400 volt 3-phase power outlet. I couldn't find anyone selling just the box. Everything I could find were offers where people sold the welder together with a box and for rather high prices. I also couldn't find any technical information, and that's why I contacted Dalex via email. All I asked for was any form of technical documentation or even just a pinout of the connector. But they did not really answer my question and instead asked me to just buy a newer version of the same welder. and I'm frankly not very impressed with that response. See, when I send emails like that to companies, I always use my full name and tell them that I own this and that piece of equipment and that I'm looking for information on that equipment. In this case, some very rudimentary information would have sufficed. I also usually offer to pay for a manual or even a simple data sheet. In a case like this, I don't usually mention in the first email that I have a big YouTube channel and that this is their moment to shine. No, I want to know how they treat a normal person first. But hey, we probably don't need the company's help here. We just need to make some observations, and I guess we'll figure it out by ourselves like we always do. So let's open the enclosure, do some measurements, and find out what is going on here. Inside the connector we find 6 individual wires, all of which have the same gauge or conductive cross-section. Judging by the color, we can at least clearly identify the protective earth wire, green and yellow, that is connected to chassis ground. The other 5 wires though, well, they have some colors, but they don't really tell us anything, and since they all have the same gauge, we can also not deduce here that some of them are for power and other for signals, for example. Upon removing the wire guard and this metal plate here, we can take a picture of the insides. And this is what we see here. A heavy transformer is integrated into the spot welder. The transformer is potted and only 2 wires lead to its primary. That would be the black and the blue one. This tells us that we don't actually need 3 phases. It is a single-phase transformer, but it is supposed to be connected between 2 phases of a 3-phase power outlet. The other wires are just as thick as the actual power cord, but their purpose is not to handle large currents at all. They are signal wires that allow for 2 simple forms of communication between the actual welder and the box that it's supposed to be plugged into. Integrated into the handle is a contact or switch that closes once you press the welder together. Another wire then seems to lead to another winding on the transformer core. I deduce that by measuring the inductance between the contacts here. Now, while the main secondary winding actually connects to the massive copper bars, allowing for a low voltage, ultra high current output, the purpose of that third winding might be to measure the secondary current, providing a feedback signal to the circuit that controls the spot welder. So here's what I think is going on here. Looking at some of the pictures I found online, all these devices probably do is to supply the primary of the transformer with a short burst of current, which starts when the switch closes. The on time is limited to a short moment, but can be adjusted with a potentiometer. Another pot is part of a phase-fired controller, relying on either a triac or a pair of thyristors. The phase angle at which they fire can be adjusted, and by those means you can indirectly control the amount of secondary current. Too much current or too long a pulse and you will burn holes into the sheets. Too short and the sheets won't properly weld together. Right now I don't think I have the time to build a circuit like this from scratch. But here is what we can do right now to test this thing. Instead of connecting 400 volts to the primary, we will start with 230 volts instead. If that works in principle, we can then step up the voltage to 400 volts. We will also measure the voltage across the supposed third winding as we do this. For that purpose, we will try to weld these blades together. And as you can see, it works with 230 volts, but as expected, it's a little on the slow side here. We also measure a rising voltage across the auxiliary winding as the secondary circuit is closed. For that first test, we simply connected the primary between one phase and neutral. Now we will connect it between 2 phases, stepping up the voltage to 400 volts. As you already can tell, the transformer is now humming much louder, and there's a lot more current flowing. With some timing and a little bit of finesse, you can still weld manually, but you will also rather quickly burn holes into the workpiece as you are always welding with full power and with the transformer permanently switched on. I think I will be able to build my own control circuit, but I haven't found the time for it yet. So I found this old stereo system at a local thrift store. At first glance it might not seem super attractive because of the rather quaint appearance of its fake wooden facade, but the components are rather rare and of high quality, and I think I will even be able to turn this into a great looking system as well. What we have here are 3 German-made standalone devices made in the mid-60s. A Grundig brand transistor AM and FM stereo tuner, type RT40M, and a transistor amplifier SV40M. Both rather rare. The record player is a Dual Type 1219, which is definitely one of the best players that Dual made in those days. And I begin the disassembly process by detaching it from the cabinet. Back in the 1960s, Germany had an extensive audio and TV industry. Grundig was one of the biggest players, and this system is a Grundig system. However, Dual was one of the biggest, if not the biggest, manufacturer of record players in the world at that time, which is why other German manufacturers such as Grundig, Vega, Saba and others often just bought the players from Dual and integrated them into their own stereo systems. After removing the record player, I also detached the wooden door that would protect the player behind it. I will have to check the different devices and also want to change the appearance of the cabinet itself, and that is why everything needs to be disassembled. The amp and radio have a bunch of screws in the corners of their front panels. On the back side, some smaller pieces of wood need to be taken off. The black cardboard back walls are a remnant of the era of vacuum tube radios that was quickly drawing to a close when these pieces of equipment hit the market. The mid to late 60s is when most German manufacturers made a transition to fully transistorized electronics. You can find these cardboard back walls in transistor radio receivers well into the 1970s though. With stereo amplifiers, it is much more common to find complete metal enclosures, but I guess this is a special situation because these components were integrated into a wooden cabinet. This coil here has come loose, and I'm gluing it back in place right away. The amplifier can now be pulled out. The power cords are connected together because it was seen as an important feature that the entire system can be turned on and off with just one single button. The amplifier looks great, but it's a little dusty. And after removing some screws on the back side, the radio receiver can be detached as well. To my amazement, the variable capacitor is not stuck, which is very often the case with these old radios. Mechanically speaking, everything is in great condition. Before we will have a closer look, the disassembly process needs to be finished first. Everything is taken apart and all surfaces are cleaned thoroughly. You will see why that was necessary in just a minute. The radio receiver and the amplifier are then cleaned with clean wipes. Normally I would use compressed air to blow out all the dust, but at the moment I just don't have a working compressor in the workshop. One of the fuses on the back of the radio was broken. I have replaced the fuse but couldn't find the fault that caused the fuse to blow in the first place. The radio just works fine. However, I can't really show that right now without running into copyright issues. However, I connected the amplifier to my computer's sound card and we can try to play some music that I can use legally. Believe it or not, the amplifier and radio made in 1967 simply work. In the meantime, after preparing the surfaces, I apply several layers of paint to the old cabinet. Don't get me wrong, I like wooden enclosures, but only when we are talking about actual wood. This is basically cheap plywood with a plastic layer on top that is doing a very poor job at pretending to be wood. The actual components are stylish, but the cabinet itself is a little ugly in my opinion. The final layer of coat is a fresh white, and trust me, this will look great. While the paint is drying, I will have to take care of the record player though, and here we will have to do some actual repairs. I can turn the record player on and the motor starts spinning. The turntable, however, doesn't move at all, and that's why I'm lifting it off to learn why. This rubber wheel, in German called Reiprad, meaning friction wheel, is how dual players at the time conveyed the rotation of the motor shaft to the turntable. This variable diameter cone pulley here is used to run the table at 3 different speeds, as well as to allow for fine adjustment of the rotational speed. The issue here is though that the rubber wheel is no longer making contact with that pulley. After flipping the record player around and carefully placing it on some wooden supports, we can find out more about this fault. But first, let us appreciate the mechanical wizardry that you will find on the old dual record players. The town of St. Georgen, where these were made, is situated in a part of the country that is famous for watchmaking. And this is a watchmaker's approach to designing a record player. These little rubber or plastic caps here sometimes fall apart, but this one looks good. It needs to be lubricated though. And here is the reason for the malfunction. This mechanism here is supposed to put tension on the friction wheel, and normally it slides up and down with ease, so you can switch between the 3 speeds, 33, 45 and 78 revolutions per minute. It is completely stuck though and won't budge. The reason, like so often, is old lubricant that has essentially turned into resin, acting like strong adhesive, prohibiting the mechanism to move freely. Unfortunately, we need to take it apart. This little steel ball and spring mechanism would normally allow it to jump between the 3 fixed RPM settings. One of these zinc die-cast parts can normally just slide up and down on that steel guide rod. To pull these pieces apart, I apply hot air so that the resin gets soft. This only works as long as the resin is hot though. If you wait a few seconds too long, it'll be cold and hard again and nothing will move. You can now use a variety of solvents to remove the resin, like paint stripper for example or gasoline. In this case I use WD-40 and also a steel sponge to carefully scrape off any remaining gunk. The parts can now move freely again, as they should. I put the mechanism back together and also apply some new grease, and it's a joy to see this contraption back in working order. And this is what it looks like on the top side. This little wheel here can be used to fine adjust the height of the rubber wheel on the cone pulley and thus the gear ratio. And this is what it looks like when the motor is turned on. With the table reinstalled, we can see that it's actually doing what it's supposed to. The purpose of these 2 circles here is to help you fine adjust the correct rotational speed. Back in the day, you would have incandescent light bulbs in your living room. The 50 or 60 Hz flicker of these lamps would cause the lines that make up these circles to appear to stand still when you reach the correct rotational speed. The reason why you often find 2 circles of 2 sets of lines is because one is for 50 Hz, like in Germany, and the other one for 60 Hz countries, like the United States. The record player won't stop spinning and spinning, even when it's actually switched off. We'll have to open this little black enclosure to see what is going on. Also, notice that the motor can be switched between 220 and 110 volts. The German audio industry built almost everything so that it works in various countries all around the world. The amp and radio also have voltage selector switches on their back sides. Inside the enclosure, we find the motor capacitor as well as the on-off switch. This is what it looks like when I force the switch to open and close by moving the mechanism by hand. The same mechanism that activates the switch also puts tension on the rubber wheel. This mechanism, by the way, sets the correct starting point for the needle to touch down on the record. You can choose between 3 different sizes or diameters of records. You need that when you listen to 7-inch singles, for example. You set the one lever to 45 RPM and this one here to the 7-inch starting distance. What I have done now is simply oil all the little pivot points and joints, and now I move the mechanism manually over and over again until it frees up. Now everything should work, so let's try it. The record player came without one of these pins and without a pickup, but I found replacements on other old stereos that I have lying around. A record is placed on the table, and now this counterweight is screwed back as to decrease the downforce that the arm will apply on the needle. I press start and everything should work automatically now. This noise that you hear comes from that rubber cap. I applied some grease later and that took care of that noise. The record would now be playing. We can now lift the arm up and skip to another track, for example, and put the arm down again. As the arm moves all the way to the end of the last track, it should now be placed back to the starting position, and after a few more turns, we eventually hear the clicking of the motor's on-off switch. And let me just break the turntable by hand here, because otherwise it takes a while for it to lose speed. Okay, so now that everything works again, it was time to reassemble the cabinet and reinsert the amplifier, radio and record player. In my opinion, the old handles don't fit the new color, so I bought some replacement handles with a cleaner look. Now I still need to find some loudspeakers that would actually complement the system a little better than these cheap ones here. These cheap speakers don't belong to this amplifier. They are just a set of shop speakers that I use to test various equipment here and there on the workbench. And of course you can also test the record player, but once again I really can't present any cool music without running into copyright complaints, and that's why we have to listen to Geräusche in Stereo, sounds in stereo again. So all I can offer you today are the sounds of a tugboat engine accompanied by some animal noises. So that is all I had for you today. Please give this video a like if you happen to like it, because that way you can tell me what kind of content you want to see in the future. Also, if you want to support the channel a little more actively, you can make a donation. PayPal donation links are down in the video description, or you can become a supporter on Patreon under patreon.com/tpai. See you soon.